Hello student, this is Rimpa Singha Roy and welcome back to the lesson set theory. This is the second part of our lesson. In the first lesson, we have learned about the basic introduction of set. But in this lesson, we are going to learn subset, superset, universal set and some other operations and Venn diagram. So without any further ado, let's get into the lesson. First, we start with the subset and superset. First, we look at the notation. So, if I say B is a subset of A, then the notation is this. And if I say A is superset of B, so the notation is like this. It's quite similar with the less equals to greater equals to sign. Okay. Now, what is subset and what is superset? I will not give you some confusing definition. We'll directly go to the example and try to understand this. Here, I have taken a set A, which consists of 7 elements 1, 2, 3, 4, 5, 6 and 7, and there is 3 other set. Okay, so if you look at B, it contains 1, 2, 4 and all the elements of B is element of A. 1 is in there, 2, 4. So here B is a subset of A because all the elements of B is in A. If you look at the Venn diagram, this is called Venn diagram. In the Venn diagram, the rectangle represents the universal set. So what is universal set? We will learn it in the next page. But now look at the set A. A is the bigger set and B is the smaller set, and this is the subset, and it denoted by this B subset of A. Similarly, as A is the bigger one, so A is called the superset of B and will denote A like this. So this is called superset. Now similarly C, if you look at C, then C contains 2, 3, 9, 6. Here 2, 3 and 6 belongs to A, but 9 does not belongs to A. It does not belongs to A. So C is not a subset of A. Okay, now look at D. D is equals to 5, that means the null set. So null set is subset of every set. So null set is so we can write that D subset of, not D, we will directly write 5 subset of A because null set is subset of every set. Now look at this second term, which is proper set. Now before going to proper set, we will talk about the set A. If you look at A, then A also contains all the elements of A. So A is also subset of A. So here, just except A, all the subset of A, phi, B, all the smaller subset of A, which is not equals to A. That means if B not equals to A, then B is the proper subset. That means only A is not the proper subset of A, other than all the subsets of A is the proper subset of A. Now we will talk about the universal set. Here I have taken 4 set A, B, C, D. 2 finite set and 2 infinite set. But if you look at the elements of these 4 sets, all the elements are integers. So this 4 set is actually the subset of the set of integers, which is denoted by Z. I have told you in the previous part. If you haven't seen that, then please go and check out the link in the description box. So this 4 set are subset of Z. So here Z is the universal set for all this set. But if I talk about the set of natural numbers, which is n, talk about the set of integers, all of them are subset of the set of real numbers, which is denoted by R. So here R is also the universal set for all of them. Now there is no particular set which is universal set or which is called universal set. We choose our universal set with the respective sets what we are dealing with. So here the 4 sets, a set of integers are subsets of integers. So here the universal set can be Z. Similarly, the universal set can be R. So the mother set or the superset is generally called the universal set, but there is no particular set which is universal set. Okay. Now we'll talk about the intervals of real numbers. There are two types of intervals. One is open interval, two is closed interval. So open interval says it includes x belongs to R, where R means the real number set, a less than x and less than x less than b. And closed interval says x belongs to R, where a less equals to x less equals to b. So now first let me tell you that the open interval is denoted by, in the first bracket, AB, and the closed interval is denoted by the third bracket, AB. Okay. Now we'll learn the difference between open and closed interval. So if I draw a line and point AB, so the open interval is, we'll take all the points after A but not A. Similarly, in the right side, we'll take all the points before B but not B. So this is the open interval. But similarly, if we include the A point and B point in the interval, but not only the middle point but also the A and B, then it will be a closed interval. Okay. Now we'll learn two more terms or two more things, that is left open interval and right open interval. So what is that? If I draw this line again and take A and B and I include B in the interval but not A, I mean take all the points before A. So here the left side is open, so it will be called the left open interval, and it's denoted by first bracket A comma B with the third bracket, because the B side is closed, so there is third bracket in this side. The left side is open, so there is first bracket in the left side. This is the left open interval. Now the right open interval is, here will include A but not B. We'll take all the points before B but not B. So this is the right open interval, and it is denoted by A comma B in the first bracket. This is the right open interval. Now we'll learn one more thing, that is the length. What is the length of this interval? So the length of the interval is the right point minus the left point, B minus A. Here B minus A is the length of these two intervals. Okay. Now let's move to the next part. Now we'll talk about the set operation. So first we'll start with the union of set. So union of two set is denoted by this, and it's called A union B. Now the definition of A union B is, A union B contains those x which belongs to A or it belongs to B, and this sign is OR. If you don't know all the mathematical sign, then please let me know in the comment section. I will make a separate video on the mathematical sign. So now look at the example. Here A contains 5 elements, 1, 2, 3, 4, 5, and B contains 4 elements, 4, 6, 7, 2. And in the union of these two sets will include all the elements of A and B, but will not repeat the same element. So if you look at this set, we include all the elements of A and B, but we don't repeat 2 and 4, which is the common element of A and B, because we already know that set element must be distinct. Okay, you knew it in the previous lesson. Now look at the Venn diagram. So the Venn diagram shows the coloring part actually denotes the A union B. Here we include all the elements of A, B and the common element of A and B. So this is the Venn diagram of A union B. Now let's move to the next operation. Now we will learn about the intersection of sets. Here intersection of set is denoted by this sign A intersection B, and the definition of A intersection B is, it contains all the x where x belongs to A and x belongs to B. Now That means it contains all the common element of the two set. So here I have taken the same example. Here 2 and 4 are the common elements of A and B. So the intersection of A intersection A and B, that means A intersection B will be 2 and 4. So look at the Venn diagram. Here the common part of this two set A and B is this, the coloring part. So this is the Venn diagram of intersection of two sets of intersection of A and B. Now we'll talk about the difference of set. Difference of two set is denoted by A minus B. Sometimes actually the actual sign is A. This slanted minus will not actually use the exact minus. Here I have no option in the keyboard, so I have to use this. Now you use this sign when you write on the paper. Okay, now look at this. What is difference of set? A minus B, the definition of A minus B is it contains those x where x belongs to A and x does not belongs to B. Now look at the example. Here I have taken two set. A contains 0, 2, 4, 6, 8, 10 and B contains 1, 2, 3, 4, 5. Now the difference is A minus B is, here is 0. Here 0 does not belongs to B, so I include 0 here. Now the next term is 2. 2 belongs to B, so I won't include 2 in my difference, in the difference of A minus B. Now look at 4. It also in B, so I won't include this. Now for 6, it's not in B, so it will be in the answer, I mean A minus B. Now for 8, it's not in B, so it will be there. Now for 10, it's also not in B, so it will be there. So we'll include only those elements which are not common in A and B. Okay. Now if you look at the Venn diagram, you can see that I just excluded that part which is common to B. So the coloring part denotes A minus B. Now for B minus A, similarly, B minus A, only those x which belongs to B but does not belongs to A. Here B minus A, if you look at 1, it does not belongs to A, so 1 is in the B minus A. Now for 2, this is common, we excluded this part. Now for 3, it's not in A, so it is here. 4, it's also common, so I just excluded for 4 from B minus A. Now 5, it's not in A, so it is here. Similarly, the Venn diagram is B minus A is excluded the part of A. Only the coloring part shows that B minus A. So now we'll learn about the complement of set. Complement of set is denoted by A bar, A dashed and A to the power C. Actually there is a problem with the notation. It will be A with C in the head. Now we'll talk about what is complement of A. Complement of set is actually difference of universal set and A. Then the definition is it contains x where x belongs to the universal set and x does not belongs to A. Here if you look at the Venn diagram, you can see the coloring part is actually the coloring part is the A bar, that means the complement of A. Here you can see the outer part of this set denotes the complement. Okay, now look at the example. Here I have taken a set, universal set, which contains 8 elements, 1 2 3 4 5 6 7 8, and the element and the set A contains 4 elements, 1 3 5 7. So it's simple. The difference of universal set and A will be 2 4 6 8, because we have just discussed about the difference of two set. So that is called the complement of A. Now we'll learn about the power set. So what is power set? Power set is actually the set of all subset. Here I have taken one example A. A contains 2 elements, 1 and 2, and the subsets of A are 5, the null set, then 1 2 2 singleton set, and A itself is its subset. So taking these 4 subsets as element, we can form a set which is called the P of A, the power set of A. So that is the power set of A, actually the subsets of all the, set of all subset. Now the next thing is the number of subsets of A. Suppose a set A which has n element, then the number of subsets of this set will be 2 to the power n. So if we look at A, so here n of A, that means the number of element is 2, 1 and 2, 2 elements. So here the number of subset will be 2 to the power 2, that means 4. Okay, so it satisfies the formula. Now one more thing, if I say number of proper subset, then we will follow this formula. Then this formula will be 2 to the power n minus 1. So here the number of proper set will be 4 minus 1 is equals to 3, because in that case we will eliminate this improper subset. So then the answer will be 3. Okay, so that's it for this lesson, guys. We'll meet you in the next lesson and we'll do law of set of algebra in the upcoming lesson. So till then, keep learning, keep growing. Thank you so much.